Okay, here we go. I am back. So now we're talking about 7-2 rational numbers as exponents. What on earth does that mean? Well, rational numbers, we know, are numbers that can be written as fractions. And so when we're talking about rational numbers as exponents, we're talking about fraction exponents. And I know you guys love fractions, and I know you guys love exponents, so this must be the greatest day of your life. But this actually isn't that difficult. It's just a simple way of writing it. So a to the 1 over n, you'll notice this is a rational or a fraction-like exponent. That's not a negative sign. This is a rational or fraction-like exponent. Well, we can rewrite that to be the nth root of a. These are the same thing. So if I say a to the 1 over 3, that's the same thing as the third root of a. If I say 16 to the half, that's the same thing as the square root of 16, which of course we know is 4. If I say negative 8 to the 1/3, okay, then that's going to be the third root of negative 8. Now, we haven't talked about third roots of negative numbers. If you remember, we can't have the square root of a negative number, but we can have the cube root or the fifth root or the seventh root or any odd root of a negative number. And that's because a negative times a negative times a negative equals a negative, right? Because a negative times a negative is a positive times a negative equals a negative. So if it's the cube root of a negative, I know my answer is going to be negative. And what's the cube root of 8? It's 2, right? And if I don't remember that, remember I can do a factor tree. And how many do I need to get out? 3. That's 3 2's, and there's the 2. Okay? So I'm going to extend this just a little bit more by showing you this. A to the m over n, same thing as you would expect. It's the nth root of a to the power of m. So whatever's on the bottom, that's the rules of the house. And whatever's on the top stays on the top over here. This can also be written as the nth root of a to the power of m. These are the exact same thing. Okay? So let's use an example. I'm going to say 9 to the 3/2. Okay? So that's going to be the square root of 9 to the power of 3. Well, what's the square root of 9? I know that's 3 to the power of 3 equals 27. Just as easy as that. And sometimes you don't even have to write it out that way. Say if it was 9 to the 3/4, that would be the fourth root of 9 cubed. Well, we can't take the fourth root of 9 because it would end up being the square root of 3, which there's no reason to take it out. And so this would actually just be left just like this. Okay? Now, I'm about to give you a whole lot of rules. So, be prepared to receive a whole lot of rules. Now, the good news is all of these rules, every single one of them, makes great sense. So, I'm going to write rules for powers. Okay? Here's the first one. A to the power of m times a to the power of n. I don't know why we always use this. M and n equals a to the power of m plus n. The great thing about these rules is if you ever forget, you can just figure them out again. You can derive them all by yourself. So let's do an example. A to the power of 3 times a squared. Okay, well I know that's a times a times a times a times a. Well, that's 1, 2, 3, 4, 5 a's. Okay, so what do you think I'm supposed to do with these two powers? Well, to get 5, I would have to add them. So that means that I add them, a to the 5th, and that makes sense. Okay, let's do another one. A to the power of m divided by a to the power of n if when we multiply, we add, what do you think we do when we divide? Absolutely right. We subtract. Okay? It's another one. How about this one? A to the power of m, all of that to the power of n. Well, we wouldn't just add that, right? Let's do an example. Let's derive it before I even tell you what we're supposed to do. A squared to the power of 3. Okay? Well, that would be a squared times a squared times a squared, right? Well, that's going to be a times a times a times a times a times a. 1, 2, 3, 4, 5, 6. That's a to the 6th. Okay? So, what do you think we do? We multiply them. So it's a to the m times n. Okay? Now, these two are pretty important. AB to the m equals a to the m, b to the m. And it kind of looks like a distribution of the exponent. A distribution of the exponent. And that means if you're going to get rid of the parentheses, you have to recognize that it's a to the m times b to the m. Here's a good example. 4b squared. Well, this isn't 4b squared, right? It's 4 squared times b squared, which equals 16b squared. Okay? And this is actually similar to what you did on the, whenever you did a difference or sum of cubes, and you would have to square the first part of it or square the last part of it, right? You would have to square the whole thing, and a lot of people forgot to square this number as well, but you have to do that too. Okay? And then finally, we've got this little one, a over b to the m, and you can imagine it's the same thing, distribution of those powers. Okay? So let's do an example real quickly. A, b squared, c to the 12th. Okay. It's actually this whole thing to the 12th. Well, what's another way that we can write this using our exponential fractions or our rational exponents? Okay? Well, I know that this equals ab squared c, right? 12 over 3, right? Because this 12 goes on the top, 3 goes on the bottom. Okay? Well, another way we can write that is, of course, ab squared c. What's 12 divided by 3? 4. Okay? Now, all we have to do is distribute this to each one. So that would be a to the 4th, b squared to the 4th, b squared to the 4th. What do we do to these? We multiply them just like in this rule, right? See how we multiply them here? So just here we're going to multiply them as well. So 2 times 4 is 8, b to the 8th, c to the 4th. That's our answer. Okay? And let's do one more because I know you guys are enjoying this a whole lot and you don't want to end, and I understand it's a lot of fun. The square root of the cube root of x. Okay, well, that's the same as the square root of x to the 1/3, right? Okay, well, that's the same as x to the 1/3 to the 1/2, right? What do we do to these? Remember, we multiply them. If there's a parenthesis just between them, that's all that's between them, we just multiply. So what's 1 times 1? 1. 3 times 2, 6. So it's x to the 6th, which we can also write just like that. Okay? And that is the wonder that is 7-2. And you may notice that a lot of these I'm just moving really quickly through. I showed you all of these different rules and all these examples really quickly. Well, one of the things that I want to suggest to you is the way to understand these is just to do them. The way that you understand multiplication is first you understand the rules of what a multiplication is. It's essentially adding really, really fast, or fast, quickly, whatever you want to use. But for the rules of powers, we're establishing the same rules, but the only way you're going to get this is just to repetitively do it a lot, which a lot of people say, oh, you need to fully understand it. Well, you do need to understand it, but you also need to just do it a lot. Just the same way as tying your shoes, you can comprehend how the bow and tying it up together is going to hold your laces together, and you can talk about the physics and friction and how it keeps from sliding out and the tautness of it and all of that. But to be able to do it, you just need to tie your shoes a lot, or just buy Velcro. But in this situation, you can't just buy Velcro, you've got to tie the shoe. So I suggest doing as many examples, and you can see how quickly we did these examples, and a lot of the problems in your homework and in the book and on math labs are going to be just as quick, and so I suggest you do as many as you can until you get really comfortable with it.